Hello, I'm John Moore, and I'll be co-presenting with my student intern, Max Friedman. We're speaking to you from the GLOBE Partnership in New Jersey, the Institute for Earth Observations. Today's lightning talk is about Acquire, Analyze, and Apply, or AQ. The focus of this, or the theme, is a pathway to data literacy, as you can read, and this is through the fundamentals of remote sensing. So the first step, or the first A, is to acquire data. There's many ways you can acquire data. Through traditional sources on the internet, there's a host of websites and portals that you can get data. But we're looking at some things that are more career technical education oriented and how students can begin to collect their own data. So the slide that you're looking at now is a launch with Drexel University and launching a high altitude balloon. You can see to the right where the images that we received from this launch, and you can see that some of them are up on the edge of space. This balloon reached over 100,000 feet. Now think about this. This is students designing the projects, collecting their own space imagery. We also use Closer to Earth from our friends from the ARIN project and using AeroCats. So flying with kites, we can get aerial image. You've seen that project. Our project using CubeSats is a way that we're hooking to the AeroCats and using this as an option to get airborne information and imagery. Finally, a more sophisticated project that happens at Wallops every year is called the Rock On Project. And here you're going to see a sounding rocket come on to 1-0 and lift off. And so this is a sounding rocket that was built in 1 week. You can see the insides. Students built this and we launched it and got the data back all in a week, and the launch and the retrieval of the data was in 1 day. So finally, next we get to analyze the data. So now we've showed you a couple innovative ways to collect data. Now here's some other ones. So this is a thermal image, as you can see, from our nature park that we have here. This is a thermal image generated from flying drones. Those images were then thrown into ImageDray and Multispec, where you can do image analysis so students can do real analysis of real imagery. Another thing that we flew was, again, using the AeroCats. And so these were images, and this is kind of a patchwork quilt, if you will, using GIS, or Geographic Information Systems, so that you can create an image. And once you create your image, again, that's a required part, then it can be put in for annotation. And next to it, finally, is to apply. I often say that apply may be first, particularly when you're dealing with pre-college students. Because students want to know what they're doing, why they're doing it, most of the time before they start. And I shouldn't even say pre-college students, because usually adults ask the same thing. So let's look at how we can apply this. So it really has large implications in CTE, Career Technical Education. And you look at that, how that system works. It's not linear, it's not standard-based, so to speak. It's cyclical. So you have learn, practice, apply, and then do it again. Learn, practice, and apply. You can keep doing that and operate from a proficient level to an expert level. And finally, we get to the U.S. Department of Education. Just a couple weeks ago, launched a new initiative called CTE Mission CubeSat. Of course, as you might suspect, I was very happy to see this. You can read about this and their push on career technical education. So they're seeing this as a way to get this type of information out across the land. Now, I've been working on this for about 10 years since I was an Einstein Fellow at NSF working with Joe Karski. And it's very gratifying to see this raised to a national level. So Max is going to explain to you the project that we're working on and how this can tie into all that. And it's cleverly called a CubeSat. Max is a senior at Burlington County Institute of Technology. He's a pre-engine career major. He's the sole designer of the project, and he's going to tell you about that right now.
Thank you, Mr. Moore. Our goal is to bring ACube to pre-college education. To do this, I've designed a low-cost 3D printable CubeSat model. This CubeSat is controlled by a Raspberry Pi. It's 3D printable by any school, student, and they can assemble it in-house. Using a sensor board, they can collect environmental data. It also has a visual and infrared camera on the bottom. This data and and images and video can be entered into software such as ImageJ or other analysis tools. Using this, they can take the CubeSat to acquire data, they can use analysis tools to analyze the data, and using what they recover, they can interpret that and apply it to their lessons that they're trying to learn. We hope to inspire students to really take a look at environmental data collection and have a love and passion for it. Hopefully this will inspire them to further their education in CubeSats and eventually build one that can go into space later in life.
Thank you, Max. And finally, to wrap up, on Earth Day, the 25th anniversary of GLOBE, I launched something I've been working on for several decades now and introduced it to the GLOBE community, called GLOBE Satellites and Education Team, or GSET for short. So you can see there the quote is to observe the Earth and visualize the future. This was a phrase that came from my students maybe 25 years ago, and we've been working on this. It's all about using satellites, learning about remote sensing, and we can apply the A-cubed process to this type of work. Many of you are already on the team. Those of you who aren't, you can contact me and we'll get you involved. Thanks so much for listening to us, and look forward to a time when we can see each other again in person. Thank you so much.